So if I had, we have arithmetic and we have geometric. And hopefully we understand that those two things are separate. The first thing we have is we have a sequence. So this, we're going to be talking about a sequence right here. That's good. So sequence. If I want to find any term in the sequence, what formula do I use? The explicit formula. Which is what? A-N. Why is it A-N? Why did we choose A? How by just memorizing this, the formula, will this A help me? What does A stand for? Arithmetic, right? So if you see it's A-N, you know that this is the explicit formula for arithmetic. So A-N equals A1 plus D n minus 1. Okay. One thing we're getting really confused on, that I'm seeing a lot of people get confused on, is this idea of A-N. Do you guys, let me go to a new page. So, do you guys understand? Here's the sequence. We'll go with 10, 13, 16, 19, 22. Okay, so this is the sequence here, correct? Do you guys understand that this is A1? Yeah. And this is A2? Yeah. What does this right here stand for? That it's the first term in the sequence. Do you get what I'm saying then? This is your A, so A-N is just, N represents the term number. So this is term number 1, term number 2, term number 3, term number 4, term number 5. So if I asked you A5, what does A5 equal? A5 equals 22. It is the fifth term in the sequence, and I go 1, 2, 3, 4, 5. That's the fifth term. You guys get what I'm saying here? So, for my explicit, this will solve any term number. So if I want the 100th term, then I put 100 in for n here, and 100 for n right there. Does that make sense? Then we have this other formula that we don't even really need to write down too much. It was called the recursive. And the recursive was, well, let's say you wanted the A-N term. Well, the A-N term, if I'm in arithmetic, how do I get to the next term? Since I know it's arithmetic, I'm doing what to get to my next term? Adding. So what it says is, you take the term in front of it. That's why is it A-N minus 1? Because if this is the 100th term, I'm going to take the 99th term and add common difference. That's all the recursive formula was saying. After using this for a couple times, does this make it a little more clear? Then finally, we had this guy who was named Gauss. And he said, you know what? If you want to find the series, which the difference between a sequence and a series is the series is just, or the sequence is just the numbers in order. It's just the numbers. This is a sequence. What does the series do? A series takes the sequence and adds all them together to whatever place you want to stop. So it says Sn equals n times quantity A1 plus AN, all divided by 2. So if I go back to my sequence that I've already done, or my sequence that I've already done, if I say S3, That tells you that I want you to add from the first, the second, and the third terms together. And in this one, would I necessarily have to use Gauss's formula? No, because I can just add these three numbers together really easy, correct? But if I said I have S40, and I'm still using this sequence right here, do you want to keep carrying this out and make 40 terms of this, and then add all 40 terms together? If you do that on my test, you will be there all day on that one problem, and you won't finish anything. So if I was doing this, what would I need to do? I would use Gauss's formula, which says 40 times A1, which is 10, plus, do I know the 40th term? So what would I have to do? I have to go back and use my explicit formula to find the 40th term. Now, is that the last term in this sequence, or in this series? No, because this series, or this sequence goes on forever. But they've only asked me to calculate up to the 40th, so that's where the line has been drawn. So that's where it's the last term in this series, because they've said, I want you to stop at the 40th term. So I'm only adding up to the 40th one, because they told me that that's where they want me to stop. Does that make sense? So do we understand all the ones for arithmetic and what they do for us? Sometimes when I give you a series, you're going to have to use the explicit formula to find that AN. Are you with me? There's actually another thing we're going to talk about in this review too. Now, in geometric, we had formulas that were, again, the same thing. We had an explicit formula. What was the explicit formula? Gn equals G1 times R to the n minus 1 power. And that will find any of the terms in this sequence. What was the recursive? Gn equals Gn minus 1, the term before this one that I'm trying to find, and I just times it by the common ratio. Very similar to the recursive over here. Then we had Euclid, and he said if you want the series, Sn equals, what did he say? Sn equals Gn times R minus G1 divided by R minus 1. Alright, so let's go through this. Alright, number 1. 5, 20, 80, 320, I'm going to stop there. It says, what type of sequence is this? So, the type of sequence is, how do I get from here to here? Well, I try and I add 15. Okay? And then when I add 15 here, I go, nope, didn't work. Okay, times 4. Yes, that gets me to 20. Times 4. Oh, that gets me to 80. Try one more. Times 4. Yes, it got me to that. So what type is this? This is a geometric. The next term. What formula am I going to use for this? I'm going to use the recursive formula because it's much easier, huh? And since they said the common difference is times 4, I'm just going to take my calculator, I'm going to times this by 4, and when I do that, I get 5,000 120. Good?
Yeah.
Number 2. By the way, should that question take me very long on this test? Alright. Number 2 says use sigma notation to write this. Okay, so I got 6, 8, 10, 12, 14, 16. Okay. It says S6. And it asks me to write sigma notation. Sigma notation is with that funky E thing. And I've got to tell them where they're going to start. N equals what?
6.
Where's it going to start? 1. Where is it going to finish at? How many numbers are we going to have? 6. So that tells them they're going to plug in 1, 2, 3, 4, 5, and 6. Now the last thing I need is I need an equation here. The equation that I need here is the explicit form. You guys understand what I just said? This equation that goes in here is the explicit formula. Well, how do I get the explicit formula? What is this? What do I first need to decide? Is it arithmetic or is it geometric? Add 2, add 2. I quickly see that it's arithmetic. So which formula am I going to use? AN. Why? A stands for arithmetic. It should help keep these formulas separate so you know which ones are arithmetic and geometric. That's why they put the A there. So AN equals A1 plus D times N minus 1. That's the generic one. Now I plug in all the information I know. I don't know AN because I'm trying to leave it as this. We'll find any term in this sequence. What is my first term? 6. What is my common difference? 2. N minus 1. Is there anything that we can do with that equation over there that you know that we can do? What can we do with the 2? We cannot add to the 6. No, sir. You can distribute it. You have to follow laws of math. You can't just because these are side by side right here. Those don't add yet. There's a multiplication, which order of operations. I got to do the multiplication first. Equals 6 plus 2n minus 2. What can combine there?
6.
And so I'm going to bring the 2n forward, and I'm going to write 2n because it doesn't touch anything. And what is 6 minus 2? Positive 4. That is my explicit formula, and that is what is going to go right here when they ask me to write it in sigma notation. Does that make sense? I'll be looking for 2 answers on this question in the test. This is one of the answers I will be looking for. If it is not there, you will lose out on points. Now, what does it also say? Then compute. Compute means to actually add them together. Well, I have 2 things that I could do for this problem. I could actually just take a calculator, and since they're giving me, this is 1, right? This is the first term, second, third, fourth, fifth, sixth term. Have they given me all 6 terms? So what can I just do with this, since it says s to the 6? What can I do with all these things up here? Just add them in my calculator together? I'd be fine with that. What other way can I use that would I be okay with? Whose formula could I use? Gauss. Do I have the first term? Do I have the last term that they want me to get to? Do I know the n? What's the n in that? What is the n? 6. So if I wanted to use Gauss's formula, it would go 6 times, just happens that this is, remember, this is n, this is the first term. Those aren't always the same, it just happens to be that, plus 16 divided by 2. That's one way you could do that. That's S6, and that equals 66. Are we good so far with that? Any questions? in an auditorium are arranged as shown in the diagram. The first row has 3, the second has 5, the third has 7, and so on. Calculate the number of chairs in the 9th row. Okay. What formula am I going to be using? Well, let's first write. We got 3, we got 5, and we got 7. So first thing I need to decide, is this arithmetic or is it geometric? And it's a arithmetic. So for part A, if they want me to find number of chairs in the 9th row only, yes? Then what formula am I using? I'm using the explicit because I'm just trying to find the 9th term in this sequence. Does that make sense? So I'm going A, what? A, this little 9 down here, equals first term, which is 3, plus, what's the common difference? 2, what's my n? 9, minus 1, which equals 3 plus 2 times 8, which equals 3 plus 16, which equals 19 chairs are in the 9th row only. Alright, so then part B. Part B changes this question. Part B says, use Gauss's formula to calculate how many chairs would be needed for 9 rows. That means that you are going to do the first row, the second row, the third row, the fourth row, the fifth row, the sixth row, the 7th row, the 8th row, and the 9th row. You're going to put all of those chairs out. So how many chairs did you need for the first row? 3. How many did you need for the second? So if I was only going to do the first 2 rows, how many chairs did I need? 8. Does that make sense? Since we're doing 9 rows, what am I doing? I'm adding all these together. What does that become if you're adding all these sequences together? It becomes a series. And what am I calculating to? The what? 9th row equals. What is n in this case? 9. That's what this little thing right here is. Times. Gauss's formula. The first term, which is 3, plus the last term. Well, what did we just find in problem A? How many chairs are in the 9th row? 19 divided by 2. Someone said, Mr. Martin, this is 9, and then I get 22 divided by 2. And they said, Mr. Martin, 2 goes into 22 11 times. Can I do that? And I said, yes. And then 9 times 11 is 99 chairs is how many you would need to complete that. Alright, so number 4. Come on. Number 4 says, it is in a summation notation. So let's talk about this. This right here is your starting, where you're going to start at, and this is where you're going to end at. So if I wanted to complete this sequence, remember this means that I would be adding all these numbers together, but if I just wanted the sequence, I just wanted the numbers, I would plug 1 in here, right there, into the end. And 4 to the first power is 4. 4, then I have to take it and multiply it by 3. So the first term in this sequence is 12. If I wanted the second one, I would take in, and it would now become what? And 4 to the second power is? And 16 times 3 is? And so on. I could keep going. But there's no need for me to waste all that time. I don't need all those values, do I? First thing I need to understand is what kind of series is this? Is it arithmetic or is it geometric? I know it's geometric. How do I know? Something is to a power, which means it's repeated multiplication. Since it's repeated multiplication, so I decided that this was geometric, and since this is geometric, I'm going to use whose formula? Euclid's. Again, I know that it's geometric, so it's the formula that has Gn in it. Because the G stands for geometric. And I need Gn times the common ratio minus the first term, all divided by the common ratio minus 1. So I need three things. I need the last term, the final one that they're asking me to do, which I know is going to be the 7th term in this one. So actually, I know that this is going to be G what? G7 equals. Now, I need to know what is the 7th term in this, what is the 7th term in this sequence? I don't know it, do I? What can I use to find it, though? The explicit formula, which says, for explicit for geometric, it's G7 is going to equal G1 times R to the n minus 1. What's G1?
12.
So the first term was 12 times, what's my common ratio?
4.
4 is the common ratio. How do I know the common ratio? It's what's to the power, because I'm going to be multiplying by another 4 every time, right? The first time I'm going to be multiplying by 1 4. The next time I'm multiplying by 2 4. That means I've gone up another 4. So the common ratio is 4, and it's going to be 7 minus 1. So this is going to equal 12 times 4 to the 6. And in my calculator, I do 4 to the 6th power and times it by 12. And when you did that, what did we get?
4,096.
That doesn't sound right.
49,000.
49,000. Go ahead. 152.
No.
Does that make sense? Then I'm taking that number and timesing it by what? What's the common ratio?
4.
4. And I'm minusing, and I'm dividing by 4 minus 1. So in my calculator, someone do that? What would I do first? I'd multiply this times 4. I'd keep that number in my calculator. I would hit minus 12. And at the end, I would divide by 3. Because 4 minus 1 turns into 3. And if we do that, what do we get? 65,532. Does that make sense? Number 5. Wins buys a boat for $12,000. He expects the value of the boat to decrease by 25% each year. Use the explicit formula to determine the boat's value after 5 years. Okay, what you guys have to understand is we are trying to find the value of the boat. How much is the boat value? So it's worth $12,000, correct?
Yeah.
How much is it worth the next year? How would I get to that?
9,000. Decrease 75%.
So how do I get that?
75%.
It's going to be, so here's the way that you can do this problem. If you think about this. You ever go into the store and shirts are on sale? Okay? The way that I used to calculate this was a very dumb way. I would go, okay, what's 25% of this? I would take and I would do 25% of that, correct? I would get that number. It'd be some number. I would then take 12,000, subtract that number, and I'd find how much I had left. That's really dumb. Because what I could have done is I could say, if I'm taking away 25%, I really know that this value over here is going to be 75%. And all I have to do is actually take the 12,000 and times it by 0.75, and I'll get my new value. And then guess what, to get to the next year? It's going to be worth 75% of this value. So what am I going to do? I'm going to times this by 0.75. Why am I writing it like this? So you guys can see the common what? ratio. How do I know that this is geometric? What did I say every time I'm doing? Multiply. Multiply. So if I'm multiplying, it's geometric, and I just found my common ratio. Isn't that all I need? If they want me to find G what? G5. G5 equals 12,000, the starting value, times 0.75 to the power of
5 minus 4.
5 minus 1. 5 was because of this. So then I take my calculator and I put 0.75 and I hit the XY button that we talked about. XY 4, and I should get 12,000 times what? Anyone got that? 0.75 XY 4? Yeah, that's fine. Point what? 0.31, 6, 1. Now, do not touch anything in your calculator. It's a long number that kept on going, right? Leave that number in your calculator, because you want to round at the last, like at the very furthest that you can keep that number. You want to keep it in your calculator so it doesn't round it, because your calculator actually keeps it a lot farther than you can see. Does that make sense? So then, right now, you leave that number in, and what do you hit? Times 12,000. Do not round this number and then hit times 12,000. Leave it in your calculator the way it is. Hit times 12,000. And what did you get? 37,096.88 cents. And remember, this is money. That's how much that boat is worth. After 5 years. Alright, so here we go. Number 6. 6 is very similar. 6 says, the Band Booster Club sells cookies at lunchtime to earn money for new uniforms. The first day they sell 78 cookies. They expect their sales to increase by 20% each day as more students hear about the sale. At this rate of increase, how many cookies will they sell on the 7th day? Round to the nearest whole number, because hopefully you're not selling half cookies. So here we go. A. First off, let's again talk about this. Let's talk about this as they sell 78 cookies. How many cookies are they going to sell the next day? They're going to sell 20% more, which means they're going to sell 100% of this and more. They're going to sell 100% plus they're going to sell 20% extra. Does everybody understand that? So that really turns out to be they're going to sell 120% more the next day, correct? How would I figure that out? To be, what would I be multiplying by? Are you allowed to multiply by percentage? No, what do you multiply by? The decimals. So if I want to figure out how much they're going to sell, I would multiply by 1.2 each time. Does everybody understand how I figured that out? The next thing, how does this help me out big time, is I can realize that this is now what type of formula?
Geometric.
Geometric, because I'm... Well, do you see all the questions I'm talking about out loud to you? These are questions on the test you should be answering in your head. So I go, okay, I know it's geometric, so that's good. Geometric, what day do they want me to figure out? So that's G7. See that as my G6. So,
Oh boy.
boring math, I gotta make it a little bit fun. All day.
Yeah.
Alright, so here we go. How many, at this rate, how many cookies on the 7th day? We're just saying, how many cookies are they going to sell on the 7th day? Not how many did they sell in total after 7 days? That's a different question. Just how many days on the 7th day, how many cookies? So I am looking for the explicit formula because I just need the 7th day. If they wanted how many were sold all the way up to 7 days, I'd be using a series where I'm adding everything together. Okay, so here we go. That's probably B. All right. So here we go. G7, I need G1 times the rate to the n minus 1, correct? So G1 was 78 times my rate of increase is 1.2, and I'm going to take it to the, is everybody okay with me writing 6th power? And I just pop in my calculator. What do I have to do first? I have to do 1.2 to the 6th power, so 1.2 xy 6. It equals, leave that number in your calculator. Hit times 78, and what do you get?
32.9.
2 what?
32.9.
0.9. So we're going to make that 233 because they said round to the nearest whole. Make sense? That's it. That's my answer. That's a lot of cookies. I'm impressed. That's some kids that can eat. That's cool. Now, at this rate, what is the total number of cookies they would sell by the 7th day? So this means we're adding the first day's cookie sales to the 2nd day's, to the 3rd day's, to the 4th, all the way to the 7th. So what's going to be smart for me to use? Whose formula?
Euclid's.
Euclid's. And Euclid said, for this series to 7, I need the geometric one, Euclid's, which means I need what? The 7th day's total sales, which is 233, times that common ratio, which was what? 1.2 minus the first term, 78, all divided by, common ratio is 1.2 minus 1. So on the top, I get, can someone hit this in the calculator for me? 233 times 1.2? 279.6. Leave that in the calculator. Don't round. Minus 78. 201.6. And then this is 0.2. And now I hit this, I leave this in the calculator and I hit divide by 0.2. And what do you get? 1,008. Should be 1,008. And there's my answer. Number 7 is probably one of the easier questions on the test. But you do need to be careful. We go from 8 to -7 to -22 to -37. So hopefully, going from a positive to negative is kind of tricky. So hopefully you see from here to here, I'm going to go, okay, so how do I get from -7 to -22? Well, if I go back 3, that gets me to a -10. And I go back 10 more, and that gets me to a 20. And I go back 2 more, and that gets me to 22. So hopefully you follow that. You go back 7, right? So that's 7. I go back 3 more, and that gets me to a -10. So that gets me to a -10. I go back another 10, that gets me to 20. I go back another 2, that gets me to a -22. And going back means these are negative. And if I add all those up, it's a -15. So between here and here is a -15. And if I check between here and here is a -15. And between here is a -15. So to get to my next term, I'm actually going to use recursive formula because it's much easier. And so I'm going to minus 15. And when I minus 15, I get a -52, which I see is my answer B. So what I have to do is figure out it's arithmetic, and the common difference is -15. Only tricky part of that is it being negative. Number 8 says analyze the series. Number 8 is an awesome question because if I want to do the series and I want to add it all together, here's what I need to know. First off, you know it goes from 7 to 28 to 112. And if I look at that, I'm going, this jump between here and here is not the same as that jump, so it's got to be multiplication. That will help you out as far as figuring out whether it's arithmetic or geometric. And times 4 times 4. So I got my common ratio. So I look at this and I go, okay, here's what this formula needs. For my series, I need n. Well, they gave me this number, which is 114,688. But they didn't tell me that what term value that is. I don't know if that's a 10th. I don't know if it's a 20th. I don't know if it's the 5th. And I don't want to sit here and just keep multiplying by 4 until I get there. That would take too long. So we're going to talk about how to find that n. So the series I needed, I need Gn times the common ratio minus G1 all divided by R minus 1. Actually, I lied. Looking back at this, I don't need that. If I look at this, so that's what's one good thing is write down your formula and see what you need, because there's some things that you won't need. I actually don't even care what term number this is. I do not care, because if I look at this, I need the last term. That's right here. I need the common ratio. That's right here. I need G1. That's right here. And I need my common ratio, which is right here again. So actually, I don't need my term number, so forget what I said. I'm actually going to come back to this at the end and talk about how we can find that term number, because that might be something that we need later on. But for this problem, I'm just going to do it the way I need to right now. So I need 114,688, and I'm going to hit times 4, and then I'm going to minus 7, and I'm going to divide by a 3 at the end. And so I hit my calculator, I'd hit this times this, and I would hit minus 7, and at the end I'd hit divide by 3, and when you do that, you get 152,915, and if you look at that, that's answer B. Says compute the 35th term of the sequence. So this is 3, 6, 12, 24. So if I go from here, I could look at this and I go, oh, that's plus 3, but then I go here, that's not plus 3. This is times 2, that's times 2, that's times 2. So I know that this is going to be geometric. So my geometric, my explicit formula says G35 equals first term, 3, times the common ratio, 2, to the n minus 1 power. So really it equals 3 times 2 to the 34th power. So in my calculator, in those ones that I have in class, you are going to hit 2 to the 34th power. It is going to give you something in scientific notation. You're not going to touch anything except for hit times 3, and it is going to look like this in the calculator. Then the calculator is going to have this little tent like that. What that means is it's turned it into scientific notation. And remember, scientific notation means that you would, it would mean 5.15 times 10 to the 10th power. This is the 10 right here that's coming there. So if that was a 9, I would put times 10 to the 9th power. So this is scientific notation. What that means is you're just moving this decimal 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10. So actually the real number would be 51539607550. So 1, 3, 1, 2, 3. So it would be 51,539,607,550 would be the actual number, but we would turn it into scientific notation like this. Hopefully you've done that in your science class. I don't care which one you give me, but if you're using the calculator since class, which you should, this is the way it's going to write it in the calculator, and you have to understand that it's just rounded to the second term, 5.15 times 10, that's just scientific notation. And this little number that's up there in the window of the calculator is the power. All right, last one, number 10. 0.2, 1, 1.8, 2.6. So between here and here, it's really easy to see. If I add 0.8, then I get that. And if I add a 0.8, I get that. And so again, if I add a 0.8 here, so since it's adding, I know it's arithmetic, so it's arithmetic. So a n, they want the 35th term, is going to equal. And so my formula for this is a1 plus the common difference times n minus 1. So I fill that in. A1 is 0.2 plus the common difference is 0.8 times 34 because n minus 1. So I pop that in my calculator. I do 0.8 times 34. I then add 0.2. And when I do that, I get an answer of 27.4. That's my final answer. Okay, so that's all the quiz. Like I said, just give me one more second. I'm going to go over something that you might need later on. And it does not have to do with this question. That's why I am doing it separate. So if we wanted to do number 8, they asked us, what term is that? They gave us this question. So I'm changing the question to number 8 just a little bit. But this works for arithmetic or geometric. You just have to plug in the formula and work backwards. So they give us, in number 8, they say, here's your series, 7, so this is the series, 7 plus 28 plus 112 plus dot 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 plus 114,680. Let's pretend I want to know what term number is that? How far is this out to? So here's what I would do. Because I know this is geometric, I'm going to use my geometric formula. If it was arithmetic, I would do the same thing, but I would use my arithmetic formula and I'd work backwards. So here's the information I know. I know my last term, Gn equals the first term, G1, times the common ratio to the n minus 1 power. And I don't think our calculators will be able to do that. Let's do something else. I can do it. We'll show you what you got to do, but our calculators won't be able to do it. I'll do one in geometric. So you do the last value. What I want to find n is this one. So I put this in. Equals 7 times common ratio, which is 4 to the n minus 1 power. So what I do is divide by 7. I'm trying to get the n by itself, so I work backwards and divide by 7. And I get now what I would do is I want to know 4 to what power gets me to this big old number. And I could guess and check, but on calculators, there are buttons that you can hit that actually find the root. So what I would figure out is I could do this a couple ways. I could just do 4 to the 10th power and realize that that's way too high. I could do 4 to the 3rd power and realize it's way too low. So I kind of keep going in the middle. 4 to the 5th power. Nope, 4 to the 7th power, and I'm using my calculator. When I do that, I realize that when I hit that in my calculator, that this is, this right here is equivalent to 4 to the 7th. And I want mine to be n minus 1. So if this is really, when I do this, my n minus 1 is supposed to equal 7. That means that n minus 1 has to equal 7. Which I add 1 and 1, I know my nth power is 8. So what term number would this be? This would be the 8th term. I know it's a little bit far advanced, but definitely something that you guys should be able to understand. And you could do this with arithmetic. Again, you do the same thing. You plug the term number in over here, except over here I would have the arithmetic version, and this would have to be in arithmetic sequence. And then I would just work backwards and solve for n. It's definitely something that you should be able to do from Algebra 1. All right? Please watch this video a couple times. Know these formulas in and out. And I hope we kick butt on this test on Tuesday. And have a great weekend.